Hi there, welcome to Kensho Security Labs. My name is Patch Savage, and we have a bit of a fun build to talk about today, so let's get into it. Back in the before times, I used to work in an office building, doing integration support for a major software-as-a-service vendor. As part of our setup, we had these nice big displays throughout the support offices, which served as a dashboard, displaying information on the state of our support queues, team member status, and conditions on the platform itself. It's one of those things you sort of take for granted until you lose it. With the transition to working from home, I've been spending a lot more of my time in the lab, and unsurprisingly, this is causing my lab to grow in its complexity. I've noticed more and more often that I have a tendency to take down parts of my lab without even realizing it, knocking servers offline and generally causing problems until somebody else points them out to me. I need a dashboard of my own, something that can keep an eye on the various machines on my LAN and report their status to me in a way that's easy for my little reptile brain to parse. And since my personal computer shares the displays that are used by my work computer, I need to do it in a way that doesn't rely strictly on those. Now, a few years back, I did win a Twitter raffle hosted by Pyminder, the proceeds of which I used to buy this little guy right here. This is a Raspberry Pi 3A in a acrylic case with the Pyminder GFX hat programmable display bolted onto the top of it. The original plan was to use this to make something sort of like a hacker's Game Boy out of it, but since I never got around to executing on that idea, it's mostly just sort of sat on a shelf in the corner of the lab, gathering dust and serving my purpose of chaotic wizard maximalism. I'll put a link in the description below for each of these components. It's not a sponsored link or an affiliate link, but the Pyminder software supposes that you have this, so you're going to need it. Honestly, gathering and assembling the hardware for this build was the easy part. Pyminder, the actual monitoring suite, took much longer to build, about 30 hours so far, roughly. But, have Python will travel. Let's talk a little bit about what Pyminder is. At its heart, the Pyminder service can best be thought of as three separate chunks of code, working together with each other to make the device as a whole work. First, there's Pyminder.service, which exposes a lightweight and minimally secured RESTful API on the device's localhost, just using Flask. Secondly, there's an importable Python module called Pyminder.helpers, which exposes a convenience object you can use in other scripts or services to hold the details of the Pyminder service connection and expose methods through that object for you to log the alerts in each of the supported severity levels that Pyminder gives you. And finally, there's Pyminder.monitor, a runtime module that drives the actual display and handles human input events raised by the buttons on the device. Now, you've probably heard me say that Pyminder service is minimally secured, and I really do mean that. While the use of Flask and the underlying architecture of the service as an API is intended to allow for future expansion into being a proper network-facing alert aggregator, the intended use case immediately does not support that. There's no TLS protection for messages within Pyminder, and the authentication is... it's a nod toward proper authentication. It's the exchange of a shared secret. For the intended application, which is raising alerts based on cron jobs running on this Raspberry Pi, that's fine. This is probably sufficiently secure for home players like myself. But if you want to use Pyminder as a sort of distributed alert aggregator, taking in alerts from multiple hosts on the same network, I personally wouldn't recommend it with the current sort of code stack. Not yet. There is an update to fix this by adding TLS support and hardening the authentication method into something compliant with OAuth 2. That update is forthcoming. I don't have a strong time frame of when I feel like implementing that yet. All that having been said and all the warnings applied, for its intended use, the device is more or less complete. Pyminder monitor works a treat. It allows you to configure the individual display colors for both the standby mode when no message is being displayed, as well as colors for each of the 3 severity levels, which can be info, minor, or major. There are also LEDs associated with each of the buttons on the GFX hat, which are being used to show a number of conditions, such as whether or not the message has been read, whether there's more to the message to be found by scrolling the text up or down, and whether or not there are additional messages before or after this one in the queue. The buttons themselves allow you to scroll through the stack of messages as well as the text of messages, to mark messages as read, or to delete messages, as your case may be. For the messages themselves, they're displayed using a customized font I stole from another Kensho Security Labs project, Petty, but that's a bit of a digression. The 2 top lines on the display are always the name of the service raising the alert and the timestamp at which the alert was logged, with the severity indicated by the color of the backlight. The rest of the screen is effectively a scrollable window, showing the full text of the alert, which can be arbitrarily long. In fact, the alerts can be anything. They don't have to be system status messages or ping failure warnings or anything like that. Any text message can be accepted by Pyminder, including making it possible to, for example, have scheduled reminders appear on the device via some external application. That's a decent idea for another project, now that I'm thinking of it. Most interactions cause an immediate refresh of the message queue by triggering the device to poll the API. Otherwise, it's polled once every 500 cycles of Monitor's main logic loop. The version of the software that was demonstrated in today's video has already been published, and it is available at the GitHub link in the description below. Keep an eye on that repo if you're interested in this project. For the time being, it's going to be how future updates are released up until we get to the point where it's appropriate to make the package pip installable, which will be the version 1.0 release. If you liked this video, and you want to see more videos about KSL projects, like build logs for the 3rd generation virtualization lab, devlogs for Petty, or other related things, please hit the subscribe button and give this video a like. If you have any questions, feel free to drop them in the comment box below. And finally, if you want to support the work we do at Kensho Security Labs, including videos like these and the development of free open source software, consider following the GitHub sponsors link in the video description. It's like Patreon for developers. Regardless, thank you very much for watching, and I'll catch you next time.